Um, so we're recording. If anybody has any objection, please get off. And so today we're going to hear about the Long COVID project team update, which I think will be really interesting. Melissa, Haendel, Emily, Andrew, and Richard will be talking. But first, upcoming N3C community forum presentations. Next slide, please. This one. So next week, N3C community forum is canceled due to the MLK weekend. And after that, we'll hear about associations between HIV infection, clinical spectrum of COVID-19, population level analysis based on N3C data. Following that, week after, we'll hear about NLP, specifically findings, recommendations, best practices for multi-site EHR-based clinical research powered by analytics such as NLP. And then February 7th, sex and organ-specific risk of major adverse renal or cardiac events and solid organ transplants recipients with COVID-19. Okay, next slide, please. And so N3C continues into 2022 going strong with 69 sites having released data into the pipeline, 280 sites with having DOA executed, and 3.65 or 3.66 million patient cases in N3C is quite remarkable. Next slide, please. And to the feature presentation. So Melissa, are you going to be taking over the screen?
I will.
Yeah, actually, Richard, because we have a live demo that we're going to do. So,
great. Okay,
yeah.
Fantastic. Okay, Richard, thanks. Looking forward to it.
All right.
Okay.
Go ahead, Melissa.
Okay, so we're really excited to present to you the work that we've been doing on long COVID classification, and would look forward to everyone's ideas and feedback. Next slide. So you've kind of already seen this, but since we just had a reminder, we can move on. So just wanted to remind everybody about our pipeline, and when we think about how we're and this is really just a reminder in particular for all the domain teams and analyses and DOR projects that are being done, to remember that while having harmonized data is a wonderful thing, that there are differences between the CDMs, and those differences can lead to some lossiness or misinterpretations out the other end. We have seen that in the long COVID work, and I'm sure many of you have seen that as well. The data quality group has really thought long and hard about how to document and share that information. And we have a slide at the end that has a manuscript that talks about that. So I just wanted to remind folks about that. Next slide. So this is really kind of illustrating that data quality issue. So basically, and this, oh, sorry, I thought this was going to be at the end. This paper that's there on the lower bottom that was led by Emily really kind of documents all of those challenges in creating that pipeline. And the sort of what we call sort of a win-win situation of the individual sites, getting feedback on their data quality by looking at it in the context of the greater cohort that we have coming from all of the sites. So the data comes from the site, we do a quality review, we give feedback to the site, and then the site can actually improve their data. So we really do believe that we have been able to help improve everyone's data by combining our data and providing kind of holistic data quality assessments. And so you can see some examples of these things, and what's shown on the right are vitals frequency and COVID hospitalized patients at different OMOP sites. And just what this is really highlighting is just differences between how the sites are doing things and being able to find meaningful ways to kind of show when one site is quite different than other sites. What's different about that site? Sometimes it's that site is doing something really innovative and we want to learn from that site, and other times that site is missing something for some reason or another, or does things in a way that's less sufficient. So that's one of the ways that we've been able to visualize some of the challenges. And also, all of this work really impacts all of the long COVID work in particular, because it's so holistic in terms of spanning many different conceptual domains. So if you're, again, a domain team lead, please feel free to reach out to us if you want more information about how this is working for your particular domain. Next slide. So I'll hand this off to Emily.
Great. So many of you have seen this slide before too, but being we're going to be talking about how we're defining long COVID using N3C, we thought it was worth talking about how we define at least one of the definitions of COVID in N3C, so that you can know who we're subsetting from. So as a reminder, those 69 sites who are currently released are all providing their COVID data using these rules of inclusion. And so we are looking at the sites for anyone who had a positive COVID test. It should say PCR antigen or antibody here, to update that. Or a patient can have an ICD10 code for COVID, which is U07.1. Or from the very early part of the pandemic, a patient can have 2 or more what we're calling COVID-like diagnosis codes during the same encounter. And that period where we accept that as a proxy definition for COVID only spans the very earliest part of the pandemic, from January all the way through April of 2020. And after that point, we stopped looking for those. So once we gather up that group of people at every site, we then take each one of those patients who we consider for all intents and purposes to be positive cases. We demographically match them to 2 patients that are also at that site who happen to have negative or equivocal COVID tests and never had a positive test and never had a diagnosis code. So you can see in the graphic here, we do the very best that we can to demographically match, but because of the amount of missing information that can be inherent in EHR demographics, we sometimes have to do a bit of a fuzzy match. So in our example here, our patient has unknown ethnicity, and they are matched to 2 patients of different ethnicities because of the unknown there. So bit of a fuzzy match, but that is how we run our case control matches. And that's at a 2-to-1 ratio of 2 controls to 1 case. And then every site, once they gather up all of those patients, securely sends that set of patients along with all of those patients' longitudinal data from January 1st, 2018 to the present to N3C, after which point we subset this group to do lots of research that you're all doing, but also our long COVID study. Next slide, please. So this is the meat of the long COVID work that we've put out so far, although I think that all of us on the research team would agree that this is just the start of a longer long COVID effort, particularly as part of the Recover initiative. Right now, this paper exists as a preprint and is in review right now. We're going to talk a little bit about the details of the analysis that we did, and then some of the next steps that we see as following on after this effort. Next slide. So I know this is very teeny tiny, so I apologize for having to take a magnifying glass, but basically what this diagram is showing, and it's available in the preprint and you can make it larger to make your eyes feel better, but this is showing how we are doing that subsetting of the overall N3C population that I was referring to. So I think we have something like 10 million patients in N3C right now, and that includes both the cases and the controls. But for this particular study, where we are looking to define patients who potentially have long COVID, we are not using the controls for this particular research question. And at the time that we ran this analysis, when we were defining who was positive for COVID, we had probably around 2.5 million patients in N3C at the time, although it's more now. And so we started with that group of people, but then we, as many of you have done in your own studies, have made our own definition of positive for COVID that is stricter than the generic N3C definition. And, you know, for the N3C phenotype to pull patients in, we do cast a wider net than we suspect that most studies will want to use. And the same is true here. So just as an example, even though anyone with a U07.1 diagnosis code gets brought in to N3C as a potential positive case, for our study, we made sure that either you had a positive test that was not an antibody test, or you have a U07.1 diagnosis specifically from an inpatient or ER visit. We did that just to sort of narrow down on this group that we felt relatively sure had COVID. It does not mean that those are the only people with COVID. There are plenty of missed cases, and that's something that we're looking into sort of tracking down for future work. But for the purposes of this study, we wanted to make sure that everyone in the cohort pretty much had COVID. Once we've done that subsetting, we then had 3 N3C sites, now 4, but 3 at the time, who generously sent us patient IDs of patients who had visited the long COVID specialty clinics at those sites. And with that data in hand, we were able to have then a set of patients who we considered presumptive long COVID because they went to the long COVID clinic, and then not long COVID because they didn't go to the long COVID clinic. There are lots of caveats with those definitions that we would be happy to get into, but for the purposes of this subsetting, those are the 2 groups that we laid out. And then similarly, to subset even further, we knew that some of those patients were hospitalized with COVID when they had their acute illness, and many of those patients were not hospitalized. So you can see here as we go down this tree that we're subsetting patients down to the 3 sites that submitted their long COVID clinic data. And then further than that, we're subsetting into hospitalized and not hospitalized patients. And then further than that, we're subsetting into the patients who did go to the long COVID clinic and did not go to the long COVID clinic. At the end of all of this, we use these data to train a machine learning model to try and recognize the patterns that differentiate the long COVID clinic patients from the not long COVID clinic patients. And then finally, when that model is trained, we're able to run that trained model on all of the other patients in N3C that have a minimum amount of data available about them, and try to see which patients in all of N3C may be most likely to have long COVID. Next slide. And so for those of you who look at assessments of machine learning models, you may be familiar with this type of figure. And what this is showing is the performance of each of our 3 models that we built to identify potential long COVID patients. So all the way on the right side, I'm actually going to go from right to left, you'll see our all patients model. So that's where we don't differentiate between patients who are hospitalized with COVID and not hospitalized with COVID. We just put everyone together in the same bucket and train a model to see if it can recognize the patients who ended up in the long COVID clinic versus not. And the performance was very impressive. We felt really good about that. But we also knew that there are significant differences in the clinical characteristics and outcomes and trajectories of patients who were hospitalized with acute COVID versus not hospitalized. And so it was really important for us to also build separate models to cover each of those populations separately, and we did so. And in this case, you'll see that our hospitalized model in the middle did a little bit better than our non-hospitalized model on the left side. A couple reasons for that. One is that many of the patients that were sent to us from the 3 sites were hospitalized patients. So many of the patients that ended up in the long COVID clinic were perhaps coming off of a hospitalization, even if it was months later. And another reason is that for those of you who are familiar with working with EHR data, hospitalized patients tend to have a lot more data available about them. So there's a lot more for the model to grab onto with those patients, and that may have been a factor as well. Next slide, please. I'm going to turn it over to Andrew, who will explain what you're looking at here.
Okay, these are SHAP plots showing the feature importance for the 3 models, non-hospitalized on the left, hospitalized in the middle, and all patients on the right. And essentially, each dot here represents a patient and a single prediction on that patient. And the farther away the dot is from 0, the more impact it has on the prediction. So far to the right means that for that patient, that feature was strongly predictive of having long COVID. So for example, difficulty breathing in the non-hospitalized population and dyspnea are both far to the right. They're red because that is positive. There was a presence of that diagnosis. And as another example, let's pick one, younger patients. It's a little bit more complicated, but there's a cluster of younger patients to the left here where you are seeing a prediction of not having long COVID. And the same thing is true for the COVID vaccine. The presence of the COVID vaccine in the hospitalized patients, those are red, that's a positive sign, and they are on the left side predicting not having long COVID.
All right, so Andrew was nice enough to apply this model to all the patients that qualified for inclusion criteria, and then we're able to create these maps to give an idea of where these patients are coming from throughout the entire N3C cohort. So what we're seeing here are two maps that are showing pretty much the same thing. The one on the left is if we use a 50% threshold based on the machine learning prediction coming out of the model we just discussed. So saying anybody that we say is more than 50% likely to have PASC has PASC. And then a more conservative estimate saying, well, like we have to be 90% sure over here on the right. And in any case, you can see by the dark colored states that there's, for each of these, there's at least 10,000 or 1,000 patients per state. So we have a pretty good geographic coverage. So what I'm going to show now is a couple demos. So the first thing is the dashboard, which I don't know, Andrew, do you want to talk about the dashboard? You're the one that made it.
Okay. Sure, happy to. So this dashboard just lets you adjust the threshold for the prediction, 95 being the highest we allow here and 50% being the default. And then you can see, given that threshold for the model, how many patients in the enclave do we predict have long COVID? And of course, this is the denominator here is only those patients with sufficient data, and there are about 1 million of those in total. So at a 50% score threshold, we have about 22% of that million being predicted as having long COVID. And the time course for both not long COVID and COVID are shown below that. And then some of the most important features that go into the model, including the oxygenation related diagnoses of dyspnea and hypoxemia and difficulty breathing are shown, and how their relative frequencies in the two populations are shown, as well as their relative utilization. The utilization and the oxygenation features were some of the most important in the model. And as you lower the threshold, you have more people with these features that are not being predicted as long COVID. So it gives you a sense of there is no sort of right answer for this threshold. If we're playing with sensitivity and specificity here, and this gives you a sense of the consequence of that threshold decision.
Okay, so I wanted to show a little bit of how we made the maps. So this is back inside the enclave, and these are pieces of logic that we're going to template pretty soon. But I just getting a little bit into the nitty gritty for those of you who've been working into the enclave. We do have the person table and location table. These are all things that you can get directly from the data catalog. But what we've done here is take and attempt to find exactly what state these patients live in. There's some additional code that we've written here that validates, for example, to make sure that the states that the locations determine are real. We go look up by zip code to try and find what state they are located in. And also we have this extra piece of logic that attempts to find if a location is missing for a patient, what is the most common state that patients from that site live in. So, if there's a hospital, if there's a patient that's missing their location, but they go to, hospital 123, and we look and we see that the state of Georgia is the most frequent for hospital 123, we're just going to impute and assume that that patient is coming from the state of Georgia just for the purposes of this visualization. So all the red stuff is external data sets or things that you can get directly from the data catalog. And then the pink piece of data down here is whatever the user is going to provide. In this particular case, you can see that these are the almost 1 million patients that the predictions for long COVID are being made upon. And then we just take these, join them all up, and we have some example plots to make the maps that we just showed back here. And we should note just the flexibility of the platform. There's SQL, there's Python, and there's R all mixed together in harmony. The final thing we wanted to show today too was the dashboard. There have been a couple new additions, notably the data model is showing up with the sites. We have sufficient sites to start providing that information. And then as motivation for the rest of us, as we continue to publish things, the publication page is tracking all the various pieces of research that we're putting out. So if you have a publication that's not on here, please let us know. We're trying to keep this up to date as much as possible, showing about a dozen publications and about a dozen more preprints that have come out of N3C. So back to the slides. So I'd also like to talk about one of the emergent properties that this whole long COVID process is making available. We are partnering with sites to both validate and improve this computable phenotype based on the machine learning that you saw earlier. So what we are getting from all of our data partners is, of course, electronic healthcare record data. And what we are providing to the community is this computable phenotype, or the logic that helps us find which patients have PASC. But additionally, the 4 sites that have helped us in our pilot study by providing training labels that Emily talked about. So 4 sites are giving us information about which patients are coming from long COVID clinics. And that's what we're using now. We're hoping to expand the universe of sites that can also provide this data. And we've asked for that from a lot of our data partners. But what's interesting is that we are also able to, as we showed, label every patient that's in the enclave with sufficient data with the likelihood of having PASC. And so we can push those labels back to the data partners for purposes of validation, as well as for purposes of recruitment. And so this is just like a toy example of what that data would look like. There's the patient IDs that are private by the sites. We know the patient IDs from N3C, and we'd be able to push those labels back to the sites in a way that only the sites would be able to re-identify their own patients. Just to give you guys an update overall for where N3C's efforts sit within the wider Recover effort. Our milestones are focused in these key areas. So long COVID phenotyping, which we've already started on and what we've been discussing earlier today, creating that sort of core phenotype for what is PASC, what are the pieces and the characteristics of those patients. In addition, we have a mandate to cross-validate these phenotypes in partnership with other EHR cohorts and to further divide and subphenotype patients with PASC. Additionally, we're continuing to ingest data from all of our partner sites, and including improving harmonization and quality control along the way. One new piece of information, which might be new to you guys, is that we are also mandated to help address ad hoc queries coming in from the larger Recover consortium. And then finally, in what I'm calling our sort of core efforts, we're also using N3C data and labels of PASC to help evaluate risk factors for affecting the severity or the duration or the development of PASC in general, and also interventions both in the acute setting as well as long-term, also affecting the development and the severity and the duration of PASC. So I'm going to turn it back over to Melissa to talk about some external data sets and linkage.
Yep, and I know if folks will probably have some questions, and hopefully Ken's on the line and we can have some more discussion at the end. So I know we've talked quite a lot on these calls about privacy preserving record linkage and our partnership with Datavant to help support the Honest Broker, which is at Regenstrief, to help reassociate data about an individual at any given site. So the PPRL satisfies specific regulatory requirements as maintaining the data as de-identified and not being able to reverse that identity, but also supporting HIPAA compliant ability to link records. And one of the over on the right are some of the key requirements and why it's been such a critical foundation for the N3C to advance how we link data across sites and across patients. So for one, it's multimodal data analytics, and we'll talk about that in a minute. Patient deduplication, where we have the same patient potentially having related records either in the same or within the different institutions, but not otherwise captured in the same record. For cohort discovery purposes, where you want to use multiple sources for cohort discovery, and also for prospective observational linkage. So if you go to the next slide. So this is just a quick update, and it's really critical for our study of long COVID. And so that's why we wanted to, in particular, give you an update, but also remind everyone that these resources are available to anyone doing analytics in the N3C. So more recently, we have been integrating the Mortality and National Death Index. As some of you are quite aware, death data has been particularly challenging in the N3C. Different models handle it differently. There's a lot of missingness. It's been quite challenging. And so this multiple sources of death data can actually really help fill in the gaps and really help improve overall analytics where death is concerned. And then secondarily, viral variants. There's a big initiative to get institutions interested in doing submitting viral variant data, either as summary level data along with their data push as a separate table, or using PPRL. If you are an institution that's interested in participating in that, please let us know. I think we have at least 10 institutions who have signed on to do the PPRL aspects of that. We are also working on insurance and CMS data in the enclave and linking those data. So that will also provide a complementary suite of many different attributes for use in the enclave. We are now up to 47 approved external data sets. And you can see the lovely navigation tool that Chun-Li Wu had built for us for that purpose at the link provided there. Maybe we can post the link in the chat. But there are many different public data sets that are there. And if you have others that are not there that you're interested in seeing there, then please also let us know. There's information on the website about how to request addition of a data set. And so we now have a total of 18 sites with different types of data linkage agreements out of our 69 that have already have released data within the enclave. So that's really fantastic, and enough sites that we can really get going with analytics that support the multimodal analytics, cohort discovery, prospective observation, deduplication, as well as just really thinking through some of the long COVID characteristics. So for example, does vaccinations data, vaccination status and timing with respect to COVID infection change the outcomes or propensity to have long COVID? Similarly, do certain viral variants change the propensity to cause long COVID symptoms, and these kinds of questions? So we're really quite excited to have these enhancements coming as they're really critical for the long COVID work. And so just a final slide. We have a project DUR and level 3 IRB for this work. We now have 65 different researchers in that project from 18 different institutions. And you can kind of see the network of sites and people in that enclave. We are having a lot of fun trying to organize everybody into smaller subgroups to get our work done, and sort of pushing the envelope and asking for feature requests from the Palantir team in order to help support the complexity of this particular very large DUR project space. So that's been an interesting adventure, and also really kind of advancing how the enclave functions for everybody. So we'll just open up the floor for questions. I'm sure there are quite a few. I see some in the chat.
Yeah, I can address the one that just came in from David, just because this is something that we were able to accomplish recently. So David is asking if we have areas under the curve for independent data sets that were not used to parameterize the model. And we actually do. When we did this work, goodness, it must have been a few months ago now, and time really flies. We did not have a fourth site. We had our 3 sites that had submitted data, but in the meantime, between the time that we submitted this paper and now, a 4th site submitted long COVID clinic data. And with that 4th site that was never even looked at by us when we were building the model, Andrew was able to rerun the model just using that site's data. And I admit I do not have the areas under the curve off the top of my head. Andrew, I don't know if you do.
I think it was 0.82, so it was pretty good. Not as good as on the sites that we trained on, but that's to be expected, I think.
Yeah, so we felt pretty good about that, and we think that, even though we know that there is work to be done to make this more generalizable, I was really pleased that the model performed that well on an independent data set. Now, there is something that's related to that I do want to address, which is that if you look at the list of important features which are available in detail in the preprint, you'll notice, as several other folks have very validly noticed, that many of the symptoms are respiratory symptoms. And that's in some ways not surprising. But we know that, and even conventional wisdom about long COVID is showing that there are many symptoms beyond respiratory that are incredibly important to take into account. And what we are hoping is that as time goes forward and we get more and more data about patients with long COVID, not only will we be able to continue validating this model, but we're going to actually be able to retrain these models over time with more and more data and more varied data, such that the models, maybe 6 months from now, my hope will incorporate non-respiratory symptoms to a greater extent, just by virtue of having more data available to work with. So that's another thing to think about in terms of validating these models, and that I don't think, especially with the rate at which knowledge about COVID and long COVID is changing, this isn't a one and done, all right, paper's written and we have a model and we're going to use that forever. I really don't think it works that way in this case.
So there's a couple, oh, sorry, go ahead.
Did you mention the new ICD code for PASC?
I didn't, but I can, in that another development that happened after we submitted this paper was the release of, and it took a very long time, but the release of the official ICD10 code for PASC or long COVID, which is U09.9. We are just now getting into N3C. We're seeing that code come in for more and more patients all the time. And what we would like very much to do is to try to understand how that code is being used before we pin our hopes on it and say, this is a great way of identifying long COVID. It is certainly going to be a help. There's no question about it. But from our early investigations, we saw that some sites were using that code a ton. Some were using it not at all. Some were using sort of more generic codes, like there's an ICD-10 code that I don't know off the top of my head for post-viral syndrome, which, understandably providers are looking for a code to use before an official one existed. They were using that, and old habits die hard. So even after the real code comes out, maybe that code continues to be used in perpetuity. So there's a lot of really interesting issues surrounding that code that we are absolutely going to have to investigate for the recovery program.
And I think it's really, again, just similar to the data quality slide that we showed about how different institutions are coding things. It's going to be great to use some of that same visualization tooling and other sort of, attribute classification to kind of look at the differences in how that code is being applied in different contexts. And that's got to be part of any future use of that code in the model, and then also monitoring the use of that code over time. So I think it's exciting, but it's also comes with some upfront necessary analytics and monitoring over time.
So there's a question about imputing state information for multi-states. So this was just, first of all, the the amount of missing location information is usually pretty modest for most sites. But the idea is that, if one particular institution, let's say we're talking about Hopkins, because I know they're somewhere in there, but they're going to have Virginia and Maryland somewhere in there, but probably Maryland is going to be the most common state. So any patients associated with whatever Hopkins secret code is are going to be assumed to be in Maryland, just for making that map. There's absolutely no touching the actual data sites and data catalog information. This is all completely downstream. So there's nothing anybody needs to particularly worry about the state imputation, just that to make the most accurate maps that we can about incidents and our coverage, this is what we're doing.
So Andrew has a comment about clinical or demographic subpopulations of long COVID that have distinct symptom profiles. Absolutely. And you're going to get an email anytime soon about semantic clustering strategies for exactly that, to answer that exact question. I think also interesting will be monitoring, I had texted this in the chat earlier, monitoring the wave of different variants and different locations. So when we know like this, even if we don't have the PPRL for the viral variant for the patient, we still know the incidence of Omicron versus Delta in that particular region. And we can at least do that level of correlation. So that will also be interesting.
Erin asks if there's a SNOMED code for PASC. And it's interesting, I have not checked. SNOMED updates every few months. I don't know if it's quarterly or twice a year, but I would imagine that they would be slightly behind the release of the ICD10 code, but there may be a SNOMED code for it now. We were waiting for an OMOP code for it, but I think that has been released now. And in fact, if there are other questions, I can go hunting for that as well, unless someone else knows and can put it in the chat.
So I don't actually know if there's a SNOMED code yet. I haven't checked lately either. I've been out. But just to answer Erin's question, there are lots of source terminologies in OMOP that are not SNOMED. So there are other ways to get codes in OMOP that are not in SNOMED.
You can also see them in the source value, the condition source value, the PASC ICD-10 code. And then I think last I checked, the SNOMED equivalent was non-standard in OMOP, but it did exist.
Mm-hmm.
And I just found, and this is actually how it worked in the beginning of COVID as well. There is an OMOP code for it. This is the, I just put the concept ID in the chat. And yes, Brian mentions it's an OMOP extension code, which don't quote me on this because I am far from the most informed OMOP person in this room. But those codes, those OMOP extension codes are often used when there is not a standard vocabulary term available yet.
Correct.
All right.
I mean, it's interesting, again, just kind of coming back to the usage of the ICD as an example, in the face of new diseases that don't have gold standard clinical definitions, looking at the usage and looking at the subclassification over time, and then how the terminologies try to track that, and then how those terminologies are used, and then how those evolve in terms of code sets and other definitions. It's kind of an interesting, almost social science question, public health question, that's certainly worthwhile to kind of look through as we look back over our data and over the codes and code sets over the past year and a half. Information on the long COVID patients from the 4 sites available or identifiable to the wider community. Oh, and there was another question from Leonie that was related to that, Noha, as well. We will be making this information available. We have to get permission from the sites to do that first. But in addition to that, we are also making some site data improvements for some of the sites that are participating in the Recover program. And so those are also for sites that are able to provide labeled patients. We will be getting additional sites with labeled patients over the next few months.
And late breaking, actually, those patients are now available in the enclave to everybody.
Oh, very good. Perfect timing. My goodness. I thought we were not going to be able to say that.
Yeah. So it's really exciting. There is a code, which again, I'll go grab. I remember it off the top of my head because it's about 10 digits long, but there is a concept ID that is in the observation table if you're an enclave user. And if you look up all records with that concept ID, you will find all of the patients that we use to train our models. So you can go train your own models if you'd like. Let me go look up the code now.
And while I'm not going to name names, I do really, really, truly want to thank the 4 sites that contributed those labeled patients, because it was really, without that, we would not have been able to do this work. So thanks to the sites and thanks to all the new sites that are coming on board, because that information is just incredibly valuable. So thank you. Well, there we go. All right.
There's a question on linking state disability information. As in, do we plan to link it? I think is the real question.
I haven't heard, it's possible I might not have heard, but I have not heard of anyone investigating that yet. But Juby, if you want to reach out to us with some ideas, we can see about trying to get that linkage in place, and we'd be happy to talk to you about that. And maybe somebody else in the audience knows of other conversations that may have been had already. Okay.
Well, this was fantastic. Any other questions? Really exciting to see all the progress being made so quickly.
Thanks, Joel. Feel free to reach out if anyone has questions or ideas or suggestions. Just let us know.
Okay. Well, thanks everybody, and have a great week, and we'll see you same place next week. And thanks for the great work.
Bye.